Hello everyone, I am Somik, second year PhD student from ICS Cultivation. Today I want to talk about something very important that is hardly discussed on YouTube, the dynamical stability of phonon. Okay, every DFT user knows that phonon dispersion of primitive and conventional cells should be identical. But for tetragonal hafnium oxide, I got stable phonons in the conventional cell and imaginary modes in the primitive cell for same structure, which is tetragonal hafnium oxide. Only two elements are present, hafnium and oxygen. Today I will show you why this happens and why most phonon tutorials miss this completely. Okay, so let's start. So this is my primitive hafnium oxide tetragonal structure. Okay, and so here I am generating 2x2x2 supercell from my primitive unit cell. Okay, and my phonon dispersion is like, okay, so from the phonon dispersion is unstable phonon, so dynamical stability is unstable. Okay, from this structure as imaginary frequency is present here. Okay, but okay, now this is my conventional hafnium oxide tetragonal structure, same element, same structure, but it is a conventional unit cell. Okay, and here I am generating 2x2x2 supercell from my conventional unit cell. Okay, and phonon dispersion is stable. Okay, so this is a stable, dynamically stable structure it shows. Okay, but my question is, how can it be possible in conventional cell phonon dispersion shows stable structure, and in primitive cell phonon dispersion shows unstable structure? But question is, how can it be possible? I want to show you something interesting. Hence, okay, now in this folder you can see that, or you can follow that it is again my hafnium oxide primitive structure of tetragonal hafnium oxide primitive structure. Okay, primitive unit cell, and now I am generating 4x4x2 supercell from my primitive unit cell. Okay, instead of 2x2x2 supercell, I am now generating 4x4x2 supercell from my primitive unit cell, and my phonon dispersion is it's looking stable. Okay, no imaginary frequencies present here. So what are the possible reasons behind it? When I use 4x4x2, one second. Okay, when I use 4x4x2 supercell from my primitive unit cell, I got stable phonon dispersion, and when I use 2x2x2 supercell from the primitive unit cell, I got unstable or imaginary modes in the phonon dispersion structure. Okay, so how can it be possible? So possible reasons are, so phonons are real space collective vibration. Okay, unlike electronic band structure, they are not located into a single unit cell. Okay, if the supercell is too small, some intercell force constant are artificially cut up. Okay, the truncation shows up a fake imaginary modes. So in tetragonal hafnium oxide, primitive cell is highly compact and anisotropic. Using 2x2x2 supercell for primitive cell is not equivalent to 2x2x2 supercells of the conventional cell. Okay, so only when real space interaction range is properly captured, then primitive cell becomes stable. Okay, so for conventional cell, I am generating 2x2x2 supercell from my conventional unit cell, and for primitive cell, to get correct stability, we have to use 4x4x2. For my case hafnium oxide tetragonal structure, I used 4x4x2